Welcome to Chaos Orchestra, episode 1, the RobotCEO. Now, the idea of the RobotCEO is that AI does not necessarily need to mimic human intelligence in order to provide huge value. Instead, we could seek a symbiosis with AI using unique machine capabilities to complement complex reasoning and decision-making, which happens nowadays to be only accessible to humans. Now, the RobotCEO would be a symbiotic system of a man and a machine, featuring a CEO or any executive who can interact with an AI system, storing a vast index of dynamic information to both gain insight, but also decide courses of action. Now, let's look at how decisions are made in big companies. Usually, everything that is happening in a company or relevant to this particular decision is abstracted to a dozen of KPIs, presented to a CEO, and then he has to make a decision that will impact a big part of the company. Now, it's obviously nearly impossible to predict all the consequences, all the impact this decision will have. And now the question is, how many executives are actually making these decisions more or less blindly without knowing the full reach of the consequences? AI systems, in theory, have the ability to solve this problem, to process this huge amount of information and find the optimum path for a particular decision. In actual fact, the systems are usually not so robust and need a huge amount of information, data, and scenarios to be able to give a proper recommendation. And even if they would be able to do all this, wouldn't executives that is constantly watched and evaluated by the public, media, employees, stakeholders, actually rely on a recommendation of an AI system that gives nothing than a percentage of a certainty as irrational? Now, one might argue that executives trust their gut to account for all the information and data they do not have. But this is a slightly different topic, since nowadays AI systems' decisions are judged way more strictly than humans. So what if an executive could actually work together with a vast, intelligent, continuously updating knowledge base? What if the system could communicate, give recommendations, calculate changing circumstances, and all this based on instructions from a human partner? Perhaps it would be enough for an executive to know the logic of the AI recommender system, like how it was trained, under what conditions it operates best, what factors it does not include, or what algorithms it's based on, in order to understand the limitations of a particular system. Imagine being able to leverage a machine as a tool to understand in what context the AI system can produce what results, and what additional info you might need and gather to increase the significance of these results. So we do not need machines to mimic human intelligence to achieve superior results with them. Machines do not have the level of reasoning that humans have right now, and people will not be able to account for the volume of facts that are now relevant for complex decisions. Now, today we're going to talk about how a system like that could look like and what opportunities as well as challenges it will bring. Today's guest is Dan McCreary, who is a lead thinker and one of the most inspiring people in the knowledge graph space, and also the author of the article, The God Graph. Now, let's let him explain what the God Graph actually is.
What was really inspiring in this was the fact that I have a physics background and I love to follow the CERN developments. And there was a journalist who called the Higgs boson the God particle, right? And it was picked up by the media quite a bit, and it became a very popular meme. But what it really was the fact that they were trying to find one particle that would create a unifying principle that would tie a lot of concepts together. It allowed them to, they had all these theories of how the universe was created, but if they could discover this particle, they could eliminate all those others and they would have a unifying force. And so that was really what I was trying to do, was come up with a name that would bring together a lot of the ideas around knowledge graphs and systems thinking. I have several friends that have been really good systems thinker. I've always thought of it as a weakness of mine that I didn't study systems thinking much. And so what's important about this too is your focus on the ethical considerations and what we call the externalities, right? So every day I'm involved in making decisions about how to grow our internal enterprise knowledge graph. And the way I like to visualize this is, think of an amoeba, this amorphous blob of thing. And inside the amoeba is, inside the cell wall is the things you control, right? The things that you model, the things in your company that you have a pretty good sense of. And as enterprise knowledge graphs grow, that gets bigger. At the edge of the cell wall is what I call the edge of chaos, right? Edge of chaos is a highly loaded term. We should probably define it carefully. But what's important is outside of your knowledge graph is the things that you have not modeled. And we often call that the chaotic world, right? It's the things that you don't understand, yet you don't really have a good model for it. You can't make predictions about it. It's outside your knowledge graph. And what we try to do is we try to make a decision every week on our committee meetings about how we should expand our knowledge graph. And right now we do a cost-benefit analysis. We try to make a prediction of whether that additional data is going to add value to our company. But what your question was really about was about systems thinking. What about the externalities? What about the social consequences of our decisions? What about the environment? What about social justice and poverty and all those things? And to be very honest, we think about that a little bit in what we do. We have social determinants of health metrics that look at a lot of those things. We focus on interventions and suicide prevention and all those things that are very regional opioid addiction. But to be honest, we're not really modeling the outside world much. And only a very few percentage of the people that I talk to have an idea of what we could do if we modeled that. So the God graph was this idea of what would happen if we started to model and to potentially simulate the consequences of our decisions on the outside world. A good example of this is there's a lot of companies that are trying to move to sustainable energy, right? Apple and Google and all the stuff, they're building these huge solar plants to power their data centers, and they're doing carbon offset, all those things. And the reason is that they know that they want their brand to be associated with sustainability. So even though it's cost them a little more, they think in the long term they're making the right decisions because of the social consequences of that. And that's the type of thinking that I want our organizational strategists to take into account.
You just described basically the consequences and the impact that we cannot calculate or predict because of this chaos that is not modeled outside of our company. Aren't some companies maybe sometimes too confident having the models already within their company? Maybe within the companies there's still the same butterfly effect, right? Where
yes.
Maybe we're just not able to see that, but there is things or information or knowledge that is passed from an employee to his manager and from this manager to his manager over the hierarchies, and usually abstracted to some KPIs, right? And these KPIs usually are not considering every detail of that, right? So this is where we lose that. So what do you think about the chaos within and the butterfly effect within an enterprise?
A very good point. And a lot of this has to do with this idea of randomness and uncertainty in our environments. You used the phrase that we are overconfident in our models, and you're absolutely right. And COVID is a really, really good example of how we had all these models of healthcare, and they all completely collapsed when COVID came out because the rules were different. And what does that mean? It means that there are certain events that we can predict with some probability, but they're very unlikely events. Hurricanes and things like that. We can predict them, but we can't really tell you when they're going to land. And a lot of that is very true in financial markets too, right? Where you're trying to predict which stocks to invest in. But what's important about this is that when you think about technology, technology has all of these butterfly effects. Many people can look at Moore's law and they can say, oh yes, we can predict with relative certainty that processing power will increase, that memory will grow in capacity, that the cost of storage of disk will go down. Those are very, very easy things because there's literally hundreds of thousands of engineers working to lower the cost of that infrastructure every day. So there's a very predictable trend. What we cannot do is we cannot predict the breakthrough and insight of certain innovations. And one of my best examples of this is AlexNet. You've probably heard the stories of AlexNet, where they had this competition to recognize objects in images every year. And they were making 1% and 2% increases a year. And all of a sudden, this one guy who figures out how to use a GPU to train his models comes in with a 10% improvement on the scores. And then everybody uses that same model and you get dramatic increases. So you don't get a linear growth in innovation because of these ideas. The butterfly effect in chaos theory says it's very difficult to predict the impact of innovation. And most of this is software, right? Innovation in software. Hardware is going to continue to improve, but software, we cannot predict insights in algorithms. Machine learning and a lot of the AI insights, NLP, the BERT innovation, GPT-3. I've been using GPT-3 to create outlines for my blogs these days. It's just absolutely phenomenal. So those are things that it's very difficult to predict. What's interesting, though, is to try to think through the general strategic direction of these innovations and to realize that it does have an effect on the way that CIOs and CEOs do their strategy, right? Because the strategy is effectively a statement of your organizational goals. Where do you want to go? And the RobotCEO's job is to not just set that strategy, but to monitor what are all the tasks we can do to change the way resources are allocated to let us move into that direction. And that is where the enterprise knowledge graph can provide feedback, right? So a lot of systems thinking is about feedback. Many CIOs write this huge document that says, here's our strategy for the next year. They throw it all over the wall and say, good luck. But they can't monitor what's really going on at the fine grain level. And that's what I think the relationship between the RobotCEOs and the knowledge graph is, to start to get that feedback and then to use that feedback to constantly change your strategy to make sure your organization is going in the right direction.
We focus on an enterprise where a CEO has to make a decision every day, or maybe dozens of decisions every day, that, and some of them probably impact thousands, hundreds, or whatever, a huge number on employees and people, and even people outside of the enterprise, as you said. So how are CEOs making the decisions now? And how can enterprise knowledge graphs and other technologies help them to make the decisions better, or maybe just be aware of the consequences and of the impacts?
Yes, this is a great question. And I will say I'm not the world's leading thinker on what I call strategy modeling, but I have friends who are some of the world's leading thinkers. So that's very good. So a lot of this goes back to work that was done by people in US federal agencies that were trying to research how do we make a federal agency's strategy more transparent to our stakeholders. And a group of people said, well, what we first need to do is need to create a model of what is that strategy. A strategy breaks down into a set of subcomponents, objectives, things like that. It is often written. It's often written in a way that's a document, but it's not easily decomposable into a graph, so we can start to do that. But there is a representation that we can use. It's called StratML, the strategy markup language. And what's interesting about that is that inside of a strategy, it breaks down into a series of initiatives, and those initiatives are related to concepts. Those concepts can be identified at the fine grain level of everything an enterprise does. Every time you send an email, we could look at that email and look at the concepts that are discussed. So if a CEO says, we need to have better cybersecurity, that's one of our initiatives for the next year. They could create a dashboard that shows you how many people are talking about cybersecurity issues. And here's the tragedy. Many times after the CEO does these things, you see the little spike in interest, a lot of discussions, a lot of people, things like that, meetings, but then it drops off, right? So at the beginning of the year, you'll see a spike in activity, but then it drops off. So what can the enterprise knowledge graph? What it can do is provide feedback. Whenever I think of the knowledge that flows in and out of an organization, and by the way, when I use the word organization, I include every federal agency, state agency, NGO, they are all organisms that are interacting and exchanging information. I think of two things. One is how much data. I think about, do we understand that data, the semantics, the meaning of that data? And the third thing I think about is trust. Is how do you know that the veracity of that, how do you know it's valid? How do you know it's correct? How do you know it's not corrupted? Discussions about using technologies like blockchain, for example, to verify that knowledge is coming in. All of these technologies, and if you've followed the open linked data movement about publishing linked data as RDF, so that it can be published precisely and, most importantly, linked to each other precisely. The 5-star ratings for an open linked data set. If we would only embrace those, many of the huge cost of exchanging this knowledge would go down. Data.gov was a big movement for a long time, getting federal agencies to not just throw out a spreadsheet of their data of a report, but publish it in a way that we could ingest it into our knowledge graph and have it be meaningful and have meaningful impact on our predictions for healthcare. So we go back and forward on that, and I think one of the problems that we're seeing now is that with the new generation of hardware coming out later this year, and it's just going to be absolutely incredible what's happening in this industry, there's going to be even more demand for precise data, clean data, and there'll be an opportunity for entrepreneurs to come and take crazy data, normalize it, make it consistent in a consistent linked format, and then provide that as a service. And then what we can do is then find vendors that we trust that have been doing the cleanup and checking the veracity and consistency of this data.
We have a lot of data within companies and enterprises, and we now have the technology to access, process, and evaluate this data, right? Even if it's structured or unstructured, we have NLP, computer vision. So we basically have a huge power to access the data and to evaluate the results, which is great. And I mean, with great power comes great responsibility, right?
Yes,
so
yes.
There's also the bad things you can do with that. Imagine the thing that you just talked about, social networks, right? So the same technologies, right? This idea propagation and this analytics of user profiles and all this is used, and maybe not in a way that it was
intended.
You would call intended or ethical or whatever.
Yes.
Now, the same thing, but it's still a very interesting concept, right? An idea that is spread over social networks gets picked up very quickly. It gets picked up and spread even faster if it's, for example, fake news. Now, if we go back and to the enterprise context, assuming we have a knowledge graph that ties together models our enterprise, and we have the ability to process all the thoughts, ideas, and knowledge of the single employees, right? So something that we might call collective intelligence, where we can create knowledge out of all these single small sources and tie them together semantically.
Yes.
Now, so the first thing is, what do you think within an enterprise, like a big company, what value might that actually have? So how might that work? And how do you quantify if that's actually, how important or valuable that really is?
Great question. I constantly go back to the biology metaphors here. So let's just go through that a little bit. One of the things about our brain is that we have higher order areas that motivate us to do certain things. If we haven't eaten for a long time, we have a feeling of hunger, and that changes and reprioritizes all other things. What's interesting is that most of the knowledge graph systems that I work in do not have a subgraph for the company strategy or the company goals, right? So we're not modeling that. Let's assume that a lot of the work that has been done on Strat ML does get converted so that a organization could have a high-level strategy. And then remember, a lot of these organizations have many business units. Those business units may also have strategies. Sometimes they align, sometimes they don't align, right? Many companies have decentralized control models where a business unit is responsible for profitability. Take Berkshire Hathaway, right? They buy all these companies, but they don't do anything to integrate them. They're just a series of financial assets, right? And Other organizations have much better centralized control. So they have a big organizational strategy, and they have strategy meetings, and everybody goes off-site and brainstorms, and they come up with a strategy. And what if a subgraph in our knowledge graph had those strategies? What about all of the activity? How do we align all of these things with that things, and how do we do feedback and reward systems, right? Remember, our brains have constant feedback, right? If we're hungry and we eat, our stomach, we feel satiated, we're not hungry anymore, right? We don't have those feedbacks. So the first thing we have to do to build this RobotCEO is to start to model our organizational goals and strategies. Second thing we do is we have to be able to have sensors, just like our fingers and our ears and eyes, to sense what's going on in our organization, and to not have the raw data, but to create information out of that, put it together, classify it, and then we have to provide the feedback systems, right? Oh, you want this direction, but we see this strategy is not working, or this business unit has their own ideas, and so they have things that's completely conflicting. We have cases where two business units that are literally competing against each other on the same product, and they're competing against price. And what do? They drive the price down for our customers because we have two business units that we acquired in the same industry. And that doesn't make sense, right? We should be realigning that. So I should say I work for a company that has very decentralized control, so I see these issues all the time. I'm very aware of that, the fact that the strategy and the tactics are not in alignment. Imagine an army that's marching across a continent and they're all walking in random directions, right? That's what it feels like sometimes when I go into these meetings and I see our CIO having certain initiatives and a business unit is totally going in the wrong direction. So the RobotCEO is something that we desperately need to align many internal companies. But then I also want to make sure that we align it to our social responsibility pieces too. And those are it's going to take a while to get to that. So
the idea of the RobotCEO basically is that you don't just use an AI or a system to replace the CEO, right? But you're trying to, and you're also not using an AI that tries to mimic human intelligence, but you're looking for something where the human CEO can be supported by an artificial intelligence system,
yes.
Maybe powered by knowledge graphs, to create something like a symbiosis where they can use the strengths of each other. So the strength of a CEO might be the human reasoning, and strength of the AI might be being able to process huge amounts of information from within and outside a company and process unstructured data and things like that. So Dan, what do you think, how might this look like? So what might be the challenges in this symbiosis, and what might be, how could it work?
Yes, quite a bit. Right. So when we think about, I think one of the things you talk about is the scalability of a RobotCEO, right? Human beings have limited scale. We can't really watch every log feed of every operation and every check-in of all of our code. The CEO needs a cognitive assistant that they can have a dialogue with to get feedback. The idea then is a series, it's not just one, but it's a series of cognitive assistants that effectively populate an executive's dashboard. Whenever we do a knowledge graph project, we have this cost-benefit analysis scale, right? And it's easy to measure costs. Here's the number of servers, here's the software, here's the people to load the data, all this stuff. Costs are easy to measure. The productivity of our knowledge workers, we can also measure. Right? If a call center has to log into 15 different systems, that means an average phone call takes an hour. But if they have all the knowledge in front of them in a single view of our customers that displays in 100 milliseconds, those calls can be 5 minutes. And most importantly, our customer satisfaction goes up dramatically. What's hard to measure is this idea of the butterfly effect, the idea of innovation, the idea of who's going to find this most innovative report that's going to figure out insights and to save us tens, or recently we had a report that was projected, that one analysis was projected to save our company $100 million. Right? Could we predict that? No, we couldn't predict that report. But what I could tell you is if our data scientists had to go to 15 different computers, each extract that subset, normalize it, make it consistent, it would have been a 6-month project and cost $2 to $3 million. But since the data was in the knowledge graph, it wasn't this one report, it was 130 series of reports that kept honing in on finding the right data and working with our clinicians and our physicians who had the suspicion of fraud or waste and abuse, and we narrowed in. It's a discovery process. And what I like to call that is, I call that strategic serendipity. Strategic serendipity. So just like I love the name Chaos Orchestra, right? So chaos means this is this uncontrolled world, and orchestra means we're orchestrating it and we're making sense out of it. And they're oppositional terms, right? And strategies to support serendipitous discoveries have that same oppositional thinking, that you have to hold those both in your mind at the same time, that we're going to create a platform that allows for innovation, and yet we cannot predict that innovation. We cannot predict the exact report that will save us $100 million.
We made huge advancements in AI in the past decades, and there are a few. There's still a problem with explainability, right? So anything that is recommended or produced by a neural network is usually kind of within this black box that takes some input and gives me some results. And there are pretty promising approaches with explainable AI. Now, however, if you're a CEO of a company and you have to make one of these strategic decisions you were talking about, and let's say it's a restructuring of the company, right? And
reorg, yes, right.
Or maybe it's putting a plant into Germany or into US or Netherlands or whatever.
Right.
I mean, these are decisions that would have huge impact on the company's future, right? And you would probably be very careful in trusting a system that tells you, well, with 95.4%, this makes a lot of sense to put it not in the US, but in Germany.
Yes.
Right? So what would it take a CEO to trust a system like that, to trust his robot assistant? And what's the role of knowledge graphs in that?
Great question. And I'll just start out by saying knowledge graph architecture is a core piece of the explainability puzzle. And just to help you visualize this real clearly, if you have a deep learning neural network, GPT-3 is a 175 billion parameter network, and text comes in, it goes through this network, and it generates text. And if you ask, how did you generate that? It's very, or you could say how, but why did you decide that? It's very, very difficult to get that out of it. So in general, deep learning neural networks alone have almost zero explainability. And it's very important to remember that. Knowledge graphs, on the other hand, we have a sub graph of a knowledge graph, which is often what's called a semantic concept graph. Right? So I'm not saying that's the whole graph, it's a subgraph. And those are concepts that ideally a human being has curated and added to that. In healthcare, we have about 3.4 million concepts in our knowledge graph. Every drug, every symptom, every disease, every procedure, everything we could bill for, everything about how we define a patient and the condition is in that graph, and we have a written definition for that concept. Right? So when you traverse that concept graph, you can accumulate a series of definitions as you traverse that, and you can see the path. Right? And that path gives you a basis for explainability. Mm-hmm. Although it may not, I'll give you an example. When we have a very expensive drug or a procedure that a patient wants, we have this very elaborate thing called prior authorization, right? A good example is if you are infertile and you want to get a $20,000 procedure for doing IVF, we want to make sure that you've done all the due diligence to make sure that that's appropriate. Right? We want to make sure you've been seeing infertility specialists for a year before you spend $20,000 on something that is not going to help. So what we want to do then is predict whether or not we can authorize that. And what's really interesting is if we say, okay, you can have it, we don't need explanation. People don't care. Okay, you can have it. But when we deny it, we have to have an entire team write an explanation letter, which is legally binding and reviewed by our attorneys, to explain why we can't do that. And that's very, very time consuming and expensive. So explainability in healthcare is super, no physician in their right mind would take a series of recommendations and just apply it to the patient without thinking, right? Never happens. Clinical decision supports absolutely need explainability. So what we're doing is we're moving slowly on a process to make enterprise knowledge graphs have this concept of explainability. And the way I like to think of it is, and there's a lot of architecture diagrams about this, but if you just take data, put it through a deep neural network, and have an output, a three-stage process, there's no explainability. But what if between that deep neural network and an output, we put in the knowledge graph? Then our machine learning systems build concepts and the relationships and causal diagrams in the knowledge graph, which have explainability. So it's an interface between the deep neural networks and the explainable interface. And it is the essential piece that we are working on to try to do that. So knowledge graphs, I believe, are the central strategy, and there's a lot of research papers on this, that we have to be able to traverse that graph and create a written explanation based on data. And by the way, sometimes these explanations have to have a link to the research paper showing that this drug is ineffective in this combination or effective in this combination. And often the off-label use of that, we have no data to prove that those things are there. And these are very controversial, right? Because research is changing all the time. And sometimes a physician has access to research that our internal people don't, so they have to submit that research. And then we have to digest that research, look at the veracity of that, and then change our policy based on that new research. Right? So this is a continual process, and we spend millions and millions of dollars every year trying to explain things, and AI is only getting a little bit better at explaining, not nearly as fast as we'd like it to. But I think that's what we're that's a major challenge in front of us. But I would certainly say that knowledge graphs are essential to that explainability process.
Explainability, you basically need something that is a combination of symbolic AI and statistical AI, right?
Yes.
Create this brain that basically has this knowledge or aggregates the knowledge from all over the enterprise and helps. It might do it with this symbolic and statistical approach together. And we've been very optimistic that that works. I mean, we can create an enterprise knowledge graph and have this level of detail to be able to get the voice of anyone, like basically like on a social network, and be able to propagate ideas, information, and knowledge, and integrate them into this decision making. Now, to be the devil's advocate, how would you do that? How would you put in the knowledge that it's partly in the heads of experts, right? Who sometimes have more information than a database, right? Who people who've been for 34 years in the company. How do you provide all this information, make it accessible for the CEO and the robot assistant to be able to use it and to make decisions based on that?
One of the metaphors that I often use is the metaphor of Wikipedia, right? Why do we trust Wikipedia, right? And the answer is that there are a lot of people watching Wikipedia to make sure that that knowledge is trustworthy. And when Wikipedia first started, I was very, very involved in it because I really wanted to understand it. I think I had something like 15,000 commits to Wikipedia that I did over the first couple years to try to understand it. And what is important about that is that there's a continual review process where we use social networks, and there's a general ratio in Wikipedia. For every 9,999 people who are trying to make better knowledge, there's one person who's trying to destroy knowledge or put in misinformation. So we have a very strong ratio of good actors versus bad actors, which doesn't mean that all those pages are all correct all the time, but it means we have a relatively high probability that there are people watching that to make sure misinformation doesn't come in. And what the bad actors tend to learn is they spend a lot of energy trying to cause that information, and unless they're very, very orchestrated, they in general tend to fail, right? Because we have these, what I'd say, almost collaborative intelligence things that are trying to make sure that you can trust Wikipedia. Uh, we have similar processes within healthcare, right? We have people that publish articles and their peer reviews, and the peer reviews try to make sure that there's good science and things behind that. So we trust those, and there are certain websites that are promoting homeopathy, for example, that are trying to sell something, but there's no scientific basis for any of things. Vitamin industry, right? Vitamin industry is what, a $10 billion industry, but 99.99% of the people who take vitamins don't actually gain anything from them. Unless you really have certain conditions, most people eat healthy diets, you don't need vitamins, right? With some exceptions to that. So we see lots of things at the edge of what we know of, and there are these chaotic things, and we get continual pressure to try to allow certain things that there's no real world evidence behind that, and you'll see that always quite a bit. That is a continual thing, that there are people who benefit from putting things into the supply chain that there's no data behind that. So it's our job to continually build better knowledge graphs so that we can build predictive models.
The one thing is, as you said, there are these bad actors, but on the other side, within enterprise, you sometimes have this information hiding, right? So, I mean, everything transparent and accessible to everyone and usable makes you a tiny bit less important, or at least changes your role.
Human beings are complex things, and fear is a fundamental emotion that we have in our brains that prevent us from adopting new technologies. And we have to be very cognizant of that anytime we're talking about things as threatening as knowledge graphs. Because
very cultural thing.
It is a very cultural thing. One of the things I find in the Bay Area, when you work with companies like Apple and Google and Seattle and Amazon in Seattle and Facebook and Twitter and things, their entire existence was predicated on the ability to scale, right? Everything they do, everything in their culture, everybody they hire, all of their onboarding, all of their training is about scalability. And at Amazon, it is a fireable offense to put any data in a relational database that has to scale. Right? You get fired, right? And they, because they know they've had so many experiences where the older relational databases that were designed to bring everything in memory and then compare the columns, the data in two columns to resolve a relationship, those things just don't work at scale. Now, if you have a small accounting system and you're keeping track of a general ledger, that's fine. You get an exception for that, right? But what's important about this is the company culture decides that scalability is a core value. And many times when I don't know if you want to comment on this, but when I'm working with companies, scalability is not a core value, right? The core value might be financial cost effectiveness for the next 3 months. Very short-term thinking. Here's what we have to do to hit our MBOs so our executives get their bonus. And these companies are never going to make that leap from the old world of COBOL and mainframes and relational into the world of highly scalable enterprise knowledge graphs. They're just never going to do that because it takes a core set of company values that scale, that focus on that scale. And that shared knowledge is a good thing, right? And how do you do that? You have to make sure that there's controls in place so people don't have this fear that their knowledge is going to be misused to fire them or to do things that aren't in their best interest. So it's a corporate culture is a huge thing, and who's responsible for that? You know, the CEO has to really be responsible for setting the corporate culture and setting directives. And I always put Apple up there because Apple has such a focus on having decisions be made by the subject matter experts in a technology, right? Who decides on your camera technology? The people that have built all the camera systems in the prior phones, right? They don't have an accountant come in and say, you can have this feature, you can't have this feature. And companies that are driven by accounting, driven by short-term tactical thinking, they don't have the same ability that we see at Apple and Google and Facebook and these companies because of their corporate culture. And that's why, if you look at where the economy has grown in the last 10 years, these 5 Bay Area and Amazon companies have dramatically exceeded the growth of all the others because of that cultural aspect.
Most of them actually have a knowledge graph behind the scenes, right?
That is absolutely correct. That is a very, very good point. Is that, and it's not just knowledge graph, but it's really the scalability of those systems. Amazon has built their shopping carts on key value stores, which don't focus on queryability, but do different things. But in general, most of them, LinkedIn, Facebook, of course, Google's knowledge graph, their scalability is all about not just one graph sitting in one department, but on enterprise knowledge and its connectivity. And what's interesting is that's a product focus, right? Those are product people that are using that. But the product focus also has impact to the internal operations and business. You're right. Companies that focus on graph models seems to have much higher growth rates and much higher profitability than companies that are still trying to promote ERP-based systems. If you look at the trend reports on graphs, there's a company called DB Engines, and they do reports. They have a web crawler that crawls every article about different technologies, and they classify that according to their taxonomy of databases. And you can see graph is by far, interest is growing faster than anything else. But adoption doesn't necessarily track interest, right? Interest is a leading indicator. But what I will say is that because of that leading indicator, a lot of people who build the hardware to support these have stood up and noticed. And my best example is GraphCore, a company out of the Europe, UK, that has built an impressive 50 billion transistor chip that is optimized for doing graph analytics. And they're $200 million of additional funding in the last couple of weeks. So they're doing very well. And then the second thing is to understand how parallel processing, FPGAs and things, are also starting to be customized towards graph. And then the third thing that came out last year that was just completely mind-blowing was the Intel Puma project. And Puma is Intel's effort working with DARPA to build a next generation chip that is totally just focused on graph traversal. And I had always had this intuition. I'm a hardware guy. You can see the chips on my wall here that that I designed in the past. I could visualize how every circuit in these chips was being used to solve problems in the past. And I realized that pointer hopping through a graph only uses about 10% of those instructions, right? So just by throwing out the things we didn't use, we could get 10 times more cores. That's obvious to anybody who has an instruction set. What I didn't have an appreciation for is how much waste we have in the memory management. Although companies like Cray Research, Cray Graph, and Data Vortex have built FPGAs, custom chips to do graph memory management, and they've gotten huge speedups, I didn't realize what it was, the extent, how crazy the memory patterns were in graph. And DARPA and Intel did that research, and they're projecting, and this is hard to believe, a 1,000-fold increase in performance with their new generation silicon. 1,000, 3 orders of magnitude better performance. Or, flip that around, potentially 1,000th the cost of today's hardware. Now, granted, software and licenses and I/O and disk are all part of that, but the hardware to process these things is going to just skyrocket. And the reason is that we're doing systems thinking at the hardware level on graph, which we've never done because it wasn't a big piece of the market share. Now it is. Now it is starting to pick up, and we are starting to see very large implementations. So what does that mean? That means that the cost effectiveness of graph hardware is going to start to have this big role. But what's important about this is this, you're getting to the question of what's going to happen to the companies that don't adopt these things. And I think my answer is that there's going to be continued pressure on them to create divisions of their companies that focus on creating holistic views. And maybe graph is too specific a word, but I'll start to use the word connected data, right? Connected, and there's many ways to get connected data sets. You don't have to use a graph database. But the point is, a company that's running on 1,000 isolated silos is not going to be able to find the deep insights that a company that brings it all together in one system. And so I'm really, I'm very concerned that we're going to even push a lot more power into a very small group of companies that have absolute control over our world. And obviously Amazon is doing this. Facebook is not providing a service for other companies. Google has no, they use knowledge graphs internally, but they don't have a graph product. I think they're kind of on the sidelines right now, waiting for the GQL standards to mature. The language GQL working draft should be out this year. That is going to start this entire avalanche of companies that now can write their code and have it be portable across these knowledge graphs. Portability is the magic sauce that SQL people have known for 30 years, that they can build an application for Oracle and port it to Microsoft or MySQL, and they're not locked into one vendor. We don't have that portability in graph today. So when we have better hardware and we have a better language that is focused on distributed query, that will see a lot more third-party solutions. By the way, some of these companies will just buy a different, and so they'll get rid of their old ERP system and they'll use a graph-based ERP system. And the users may actually not even know that they're transitioning all their IT systems to a graph. So some of these things will happen in a transparent way. But I think what we need to do is just be very cautious about letting too much control over all of our large knowledge graphs to go into a very small number of companies. That is certainly something that we could potentially see happening. I certainly think Amazon is in the prime position. Their current graph project is designed to be easy to deploy on their cloud, but not an enterprise solution. But they potentially could add a lot more resources than a lot of other companies. So I think there's still a lot of room for innovation. I think when GQL comes out, there'll be a whole list of new companies that will offer turnkey solutions that use graph as a backend, but you may never know that. So it's going to be a very, very crazy year towards the end of this year as these both hardware and software solutions really start to mature.
How far away are we now from this RobotCEO that can see through space and time of his enterprise and be able to aggregate all this knowledge to make intelligent decisions and be aware of all the consequences?
There's a very famous quote by a guy named Paul Sappho. And Paul, his quote is, "Never confuse a clear view with a short distance." Right? A clear view is the direction the industry is going. A short distance is, can you predict the time that's going to take? And I always resist giving dates to this, because with innovation, you cannot predict these things. And AlexNet and BERT and GPT-3 are three incredible innovations that I could not predict. What I can tell you, though, is that knowledge graphs are getting to be that state where there's going to be some incredible innovations in the next couple of years. And I think a lot of the discussions that you have led on the RobotCEO and strategy and having a strategy component of our knowledge graph is going to be central to those innovations. What I will say, though, is that this is something that we cannot stop, right? It is a trend that is just going to keep going. Graphs are going to get bigger. They're going to get faster. They're going to be easier to use. They're going to be easier to program. There's going to be better natural languages. The dashboards that we create will have diversity and variation, and we'll have better, and even we're going to have physicians that can write innovative queries that find deep insights in clinical data. We're working on all those things now. Right now, we have to hire subject matter experts in graph query to work with physicians to find these deep insights. And we want to automate those things. So the direction is very clear. You can't stop that direction. That enterprise knowledge graphs are going to continue to grow in complexity, and they will continue to grow in specialization. There's going to be subgraphs in this large graph about different aspects: the security, the people, the customers, the C360, the goals, the monitoring of every task and every project and every screen and every email and all those things. Those are natural. They're all going to mature. What I cannot tell you, though, is when. But I can give you some guidelines here. I think by next year, we will have at least a dozen companies that are all offering a standard LPG query language, a GQL, right? So by end of 2022, we'll have a dozen companies that are all competing in this distributed native labeled property graph, which Tiger Graph kind of owns that market today, but we'll see a lot more diversity in that. We will continue to see software packages that integrate machine learning. Neo4j's Graph Machine Learning Library is a fantastic example of that, where they are really upping the game to say that data scientists are going to have a seamless ability to do things like build embeddings for every vertex in the graph. And by next year, I believe that you're not going to be a player in the graph movement unless you can integrate machine learning, and every vertex has an embedding, everything. And that means I can compare it, and I can predict, and I can recommend. I can recommend a movie, I can recommend a drug, I can recommend a procedure just by loading my data into these smart knowledge graphs, right? So I think by next year, that's going to really shake out the market. I think a lot of companies that have been trying to promote scalable relational databases are just going to hit the wall because they cannot use the new hardware, they can't use the query languages, they can't use the graph machine learning. What's hazier is what's going to happen in 3 years. And that's going to be the synergistic relationship of scalable graphs that have highly specialized subgraphs and machine learning and natural language queries on that. And that's going to promote a whole new set of vendors that provide integrated cloud-based turnkey solutions for almost any industry, right? That a turnkey ERP that's a knowledge graph, right? I want to start up a new company. I open a cloud account. I load some data. I get some customers. I harvest data. I find some insights. I offer a service. I refactor that knowledge, and I provide that knowledge to other companies that want to absorb that knowledge, right? So that's going to be a huge, it's a 3-year time horizon. You're going to see huge knowledge integrators and service providers and all the things we talk about. I want to move my plant. I just go to a service. I say, here's the plant, here's the outline, predict the cost, and it will give me a map of the top things because it has geospatial reasoning. It knows how to use NLP to find the policies and the incentives of every jurisdiction. It's all machine readable. All the things that Tim Berners-Lee is talking about, the semantic web being the readable web, those things, I think in 3 to 4 years are going to really start to change innovation. And then beyond that, 5 years, I have a hard time doing it. Everybody says, Dan, when do you think we're going to have EKGs turn into Skynet, right? Where they're going to be self-aware. And 10 years is a good time frame that we'll have graphs that start to do their own planning, right? So we have a strategy and we have tasks, and they will start to predict which tasks they should work on and then start to use resources and assign people based on that. And, people assignment today is just a very primitive thing, right? It's so political about you're finishing project A and you can only work on projects within your department, but your skill sets may work on a different department, right? So this tearing down the org chart, knowledge graphs are going to have a huge impact on predicting which projects your skill sets would work on, completely destroying rigid organizational org charts, predicting which classes you should take, predicting which mentors you should have, right? Predicting what knowledge, which conferences you should go to, right? Which talks you should listen to. You're going to be able to have your knowledge graph predict which skills you need to be most effective in your organization, right? And those things really start to make you think about when you open your chat window in your company, that you'll have that almost a Skynet-like experience where it is conscious, it's aware, and it knows about what your skills need to be to help the organization move in the right direction. So that's my long-term prediction. I'm not going anywhere after that.